Okay, for today, I want to ponder something. That is a vector. A lot of people are getting confused on vectors and points. Do you get if I had said that is a point? It could look exactly the same. Like, there's no way to tell just by looking at three numbers whether that's a vector or whether it's a point. That's important. What's the difference? Does a point move? Does a vector move? Yes. So when it's a vector, it's a move of 2, 3, and 4. And it has a distance that it travels. Does a point travel any distance? No. So you got to know the difference, and you can't tell by looking. So it'll tell you. Now, if it does this, a lot of people are not sure then what the difference is. Oh, X, Y, Y, great. X, Y, Z. A lot of people are not sure what the difference is then between the black numbers here and the red numbers. What is the difference? Now you can tell which one is a point and which one is a vector. How can you tell? Because it's in a certain form and you're used to that form. Can you tell now that 2, 3, 4 is a point? Yeah, I wouldn't have to tell you. You'd be able to look at it and go, that's a point. And then the thing next to the T, that's the vector. All right. I want you to ponder this. What if I put a 2 right there? Would you agree that that 2 could multiply in and make this a 2, a 4, and a -6? Do you get what I mean? It would just multiply in there. All right. So that brings up this important point. If I wrote this equation next to the first one, x, y, z equals, let's say it's 590 plus, let's say it's r times 2, 4, -6, are 1, 2, -3, and 2, 4, -6. The exact same vector? That should hurt your brain a little bit. Are they the exact same vector? Well, wouldn't the exact same vector have the exact same magnitude and the exact same direction? So the reason it hurts your brain a little bit is that they're kind of alike. So the ones I'm talking about here are, I'm going to highlight them, these two. They're kind of alike. But, here, I'm going to take this 2 out now, just to make it clear. Comparing the 2 highlighted things there, they're kind of alike. But one of them's twice the magnitude. But aren't they in the same direction? Yeah. It's kind of like a 3, 4, 5 triangle. You guys know that the 3, 4, 5 triangle is a thing, right? Do you get if I double everything? It would be 6, 8, and 10. And if you ask kids, are these the same triangle? A lot of them be like, well, kind of. Because they're kind of the same. But definitely the magnitude is bigger, right? So it's like that on vectors. So if I had a 2, 3, 4 vector and a 4, 6, 8 vector, these are both vectors now. I better tell you that with a name. Let's say this is vector V and this is vector T. No, I don't use T. A lot of times we use that for the little number in front of the vector. So let's use this vector R. Okay. Would you agree that those are in the same direction? Would you figure out the magnitude for both of them? Just take a second, figure out their magnitude. So this really stumped people last hour, so I'm trying to make sure that I get this across. These are not the same exact vector because they're not traveling the same distance. But there's 2 parts to a vector. Its magnitude and its direction. And maybe they share the same direction. And this is the thing that we really haven't talked about much. I could, if I wanted to, kind of factor out a 2, and oh my gosh, factoring happening again? It always comes down to factoring. Look at that. And now they really look a lot more alike, don't they? Just the one's twice as big. Okay. So do you get that those are in the same direction? But one has twice the magnitude of the other. What was the magnitude of V? Magnitude of V. Geo, have you got the magnitude done yet? It's the square root of. You can tell me what you're doing in your head. It'll be fine.
It's the square root of 20.
20 what?
29.
Can anybody verify square root of 29? Okay, good. And then the other one, I'm just guessing here, it's going to be the square root of, well, about double 29. You know what I mean? So twice that much. Okay. So I could say 2 square roots of 29. See what I'm saying? But let's just actually make sure that actually works. Then that's like 29 times 4. Square root of 30 times 120. Subtract off 4, 116. Can anybody verify that? Okay, cool. Now I know you might look at these two and not notice that this one and this one are exactly twice as big, but if you look at it and simplify this down to this, then you'd see it's exactly twice as big. Okay? Okay, next topic. You've seen me do this before. X and Y equals 2, 1 plus t times 3, let's say negative 2. And then I'd say make it into parametrics. Go ahead, make it into parametrics. Mr. Downen, what's the first equation? X equals?
I got x equals 2 plus 3t.
Keep going.
And y equals 1 minus 2t.
Nice. Now imagine for a moment if they just gave you that. Could you have made the original problem? It's like Jeopardy. They give you the answer. Can you tell the question? You know what I mean? Like, I know you have it written on your page, but do you get I could just say xy equals 2, 1, and then you just have to like what? Would you finish it, please? What goes here? So the question is, can you go backwards? Can you take parametrics and make them into vectors? And then you put plus. I encourage you to always put plus. You can make the numbers negative in the parenthesis. And then there's a t here, and then parenthesis, and then it's 3 and negative 2. Raise your hand if you had that one right. Okay, cool. Do you get that I can just give you 2 parametric equations and you can write a vector for that? That's what we just did. See? 2 parametric equations. Wrote a vector. Okay. I don't want to tell you everything that you're going to need to know on this little practice test, but that's a few things. Let's go back to the basics. I give you 2 points. You give me a vector. 2, 1, 5. This is a point. 7, 1, negative 10. That's a point. Make a vector out of that. And we have to know a direction to do vectors. So I'm going to say it starts here and goes to... So you always read from left to right, right? So it starts at 2, 1, 5, and it goes to 7, 1, negative 10. Can you write a vector for that? Okay, let's see. What did you get for this one? We're gonna go back in the corner. Eshoff.
XYZ equals
X, Y, Z.
215
215
plus
plus
T
T.
50 negative 15.
Anybody verify that? Awesome. So again, how did you get these numbers? That's the move. That's the vector. So a lot of people ask like, I don't know what to do the dot products with. You don't do dot products with points. That's not a thing. You do dot products with the vectors. So what's the vector? That's the vector. Is the whole thing a vector? No. Just the highlighted part. That's the vector. And you can't do dot products with points. So if you were asked to do dot products with this and another equation, the vector part is the highlighted part. All right. So, last one. I'm going to give you these two vectors and tell you that they either intersect or they collide or both. And this one got a lot of people. A lot of people struggled with the algebra, so be careful with your solving. All it would take is to mess up one of your numbers, and of course, it won't solve nice anymore. That's the vector form of a line that starts at 1, 0, 1, and the vector part is the 2, 1, 5. All right, now, the question is, if I have another one, I'll make it blue here. There we go. Now you've got two vectors if you know where to look. The question is, would these vectors ever end up crossing paths? If so, where? And if they do cross paths at a certain spot, you should be able to figure out if what time they crossed those spots was the same. Because if the time was exact same when they hit the same spot, if you're in the same spot at the same time, that's called colliding. Maybe they didn't collide. Maybe they just crossed paths at a certain spot. All right, so you use vector equations to make parametric equations. Start it. And keep going like that, and then set your x's equal. And this is algebra, and this is where some of you will break down. Take your time, do it thoroughly, carefully, because this is where your grades are made. In this class and in calculus, you're grinding out the algebra. So I'm going to pause for a second, let you try this. Okay, if you got these all written out right, this one right here is gold. Because if y equals t, then you'd be able to, wherever you see y, you'd be able to put a t. And down here's the one that goes with that. So that one's a really nice combo, and it is that 0 plus t, which is just t. And I think it's smart to find the one that solves easiest like this. And I go t equals -1 plus r. Another way to say that is even nicer, is t equals r minus 1. And now that can be plugged in anywhere else that you want to in this equation. Wherever you see a t, you can put in an r minus 1. But probably smart to like get all of your combos. That's the middle ones. I did that in black. Next I'm going to grab some in blue here. I'm going to set this one equal to this one. And that's 2 plus r is equal to 1 plus 2t. And they got two variables. Well, it's okay. You got two equations. In fact, you got three equations. Now, when I'm done with solving that set of two equations, this is an important part. I really need to make sure this last one, which I'm going to use squiggly circle to set them off from the other ones I circled in black. And that's 1 plus 5t must equal 2 plus 3r. So if you get your answer from the other two, put it in the bubble one. And if you think the answer is like 1 comma 2, like r is 1 and t is 2, well, stick them in there and make sure it actually works. Some people try to ignore the third equation, and it's a bad idea. All right. So I'm going to pause for a minute. Your goal, find out where they cross, and if they don't cross, that would be unusual, but then if they don't cross, then they can't collide, right? If they do cross at a certain spot, are they at that spot at the same time? And the time really is t or r. Time is t, and time is also r. All right. Talk to the people next to you and see if you come up with the same thing. Since I'm sensing a lot of people seem to be maybe stuck, you can put this equation into this equation and solve it. It's called substitution. And then you'll be able to figure out what either r or t is. And once you know r or t, you can stick them in here, and you'll know what the other one is. So if I know r, I can figure out t. If I know t, I can figure out r. This is called substitution. Giving you a little more time. All right, so here's how I would have done it. I would have put this r minus 1 here in where the t was, just right there. And then I would have solved it. And I would have gotten r. Save me a bunch of time. Once I put r minus 1 right there and solve this all out, I got to trust you can solve equations. What did r come out to be? Say it. 3. Raise your hand if you had 3. Okay, good. If r is 3, then I put a 3 right here. And what's t got to be? 2. So what do you do with that? T equals 2, r equals 3. Those are the timers. That's right here. Okay, t was 2, r was 3. Guess what's going to happen when I multiply that all out? Get the same exact point. And that means that they intersect at that point. But are they there at the exact same time? No. One of them's at time 2, it's there, and the other one is at time 3. So the one's a little ahead of the other, goes through that spot, and then the other one comes behind it. Okay, so where is that spot? That's the last question. All you're basically doing is figuring out x, y, and z. What is that spot where they cross? Well, it shouldn't have been too hard. Raise your hand if your group has got an answer for that. Okay, then, take the time, figure it out. I'll pause for a second again. Where? Can anybody verify 5, 2, and 11? Awesome. And that came from 1 plus 2 times 2. That made the 5. And then you just say 2 and 11? All right, 5 to 11. That's the spot where they both went through. And if you multiply this one out, it comes out exactly the same. And that's the spot. It's a point. And they aren't there at the same time, though. So that was a intersect but not collide. Okay. Now, if you're stressed about this because that's kind of hard, well, there's only maybe one question that's like that, and the rest of them are easier stuff. We've covered a lot of easier things, and you guys seem to roll with those pretty well. So this is the part where I'm going to give you a practice test, and you're going to work on that in your groups. Try to work them out, okay? Then the real test is tomorrow. So I strongly encourage you to check the answer key tonight. You're going to bring this test home. And yesterday I had a whole bunch of practice problems that would be good that you could do for practice for this test. I know you didn't do all of them last night for homework. That'd be another set of practice problems you could do. The ones I posted yesterday. Okay, that's all I got for you for today.